screen, entire screen, share. Are you able to see my screen?
Yes, sir.
Yes.
Okay, good. So what we started with mission planning, analysis, design, and also we have added very important part in the syllabus is a AOCS or attitude and orbit control system. At least you got some highlight, because satellite design, once we start without attitude and orbit control, it is not complete. So that is why we requested to give some lectures on Mr. Malik has given some lectures on attitude and orbit control. Of course, the details of more details you can find in the book what he referred. That Siddhi Siddhi book is there, so one can refer. But conceptually, you can go through that. It is a otherwise it's a quite mathematical background is required, and for this purpose, this is good enough. Okay. Now, apart from that, you also have some exposure to SDK kit. How many people could download and then operated something, whatever he has given? Students, please.
Sir, I have downloaded, sir.
So, are you able to see what happens? 1 minute. Huh? Yeah, I should see your name. Who is talking? I don't know how to see that one. It is not coming. Okay, doesn't matter. Okay, so you downloaded the SDK kit. Okay, then what are the experiments you have done on that SDK kit?
Sir, I try to follow what Genome sir has made us do, sir.
Huh.
But sir, many of us are facing the problem of software issue.
Like?
Like whenever we click compute, sir, it will take a lot of processing speed, sir, even though we have good processing RAM processor.
Yes. Normally, this all the softwares, they are very, very computer intensive. So we have to see what configuration they permit. In case is required, we can again organize 1 hour discussion with Ginu. Okay, so that will be helpful. You could have sent this thing early today itself. I would have requested him to come, or maybe next Wednesday. He prefers on Wednesday. So you please interact with Mr. Karthik, your faculty, so that we can do something more. Okay.
Okay, sir.
So now you are not able to run. And there was another software, GMAT software. Anybody could download? Hello? Somebody
Sir,
here.
sir, we downloaded only SDK software, sir. GMAT we can download, sir, if it was necessary.
No, but he was telling, GMAT software, there will be a lot of limitation on SDK software on student version. Okay.
Yes, sir.
So GMAT software, if you download, that will give a quite good exposure.
Okay, sir, I'll download GMAT as well.
Okay. So that is what we will try to do, whatever, and that is a free of cost. So we can do something more. Now, so that is what the first module is concerned. Next module, we talked about the payload. Mr. Venkatrao has given large amount of payloads. Here, obviously, in this one course, we cannot give full detail of each payload, but however, we have given exposure to all students. They will know what kind of payloads are normally used. All of you got some idea or not?
Yes, sir, we got some idea about weather reporting and...
Yes. What kind of payloads are being used for this purpose? Now, apart from that, we have given an assignment. I hope Mr. Karthik must have circulated to all of you that you make a batch of some 2 or 3 students and each one of you should give a detailed report on the payload. What kind of payload do you need? It could be communication payload, it could be infrared payload, and laser communication payload, ionospheric study payload, and so many things. Okay. So the detail should cover 10-15 pages. It should clearly indicate what is the objective of payload, what is the concept, design details in case is available, and in case any simulation or something can be done. Of course, not for everything we can do, but if it is possible, please try to do that one. And that you should submit. Okay. So what is the target, Karthik, we have put for them for assignment? Karthik has given any time for assignment?
No, sir, not yet.
So you take it by this month end.
Month end, sir. Okay, but month end we have CBT exam, sir. 29th, 30th, 1st October we have exam.
29th, 30th.
Yes,
Then
sir.
what I suggest, you can have a first week of October.
Okay, sir.
Okay. Maybe by 6th or 7th October, you should submit the assignment.
Got it, sir.
And we will, and all cannot copy each other. Batches are there, they should be different. Okay?
Yes, sir.
Because that is important. Otherwise, everybody will see the same thing and then do. And we will mark according to what is the new, very traditional payloads. They are very available, like remote sensing, this camera, and all those things are available. Something unique, if you find, and more exciting, that will give a good weightage, the quality of the payload, which people have not done, or you yourself can think what kind of payload is there, and whatever you think, probably we'll refine when you give a presentation, and we expect a presentation of 5 minutes each. So one day we'll allocate for this assignment to assess that how much you have understood. Okay. Now, the next topic, part of the payloads is pending, and which I will take up today. That is very important payload called AIS, Automatic Identification System. Okay, I will discuss little bit more, and something little bit more and straightforward system. Remaining, I assume, laser communication to some extent, very brief, Mr. Venkatrao has covered, not the communication, at least the LiDAR part he has covered. But correspondingly, you can see this is a comparatively easier project, and you can think of particular this laser communication is required when we are having satellite to satellite communications. Okay, so that part also I will say you people can study why we cannot use RF communication. The reason is the laser communication beam is very narrow and more power is injected into that beam, and so that we can attenuation of this thing will be very less. So many cases people use for laser communication for that purpose. Otherwise, the method of communication is very similar to RF, but the beam is very narrow, monochromatic, single wavelength, then it is always pointing. So you can achieve a better, uh, and since it is like an optical thing, you can get a very large bandwidth. Other aspects, you can study some sort of scientific payloads. Scientific payloads like study of sun, study of galaxy, like if you study that Hubble telescope and all those things, they study galaxy. You can also have some study like present of human being in other planet, any such kind of payloads you can think of. So this platform for payload is open for all of you. Okay, and it should be more exciting, not very routine thing. Okay. So now shall we start on that AIS? Some part I will give it today, and then I will switch on to store and forward uh, presentation. Okay. So yes, see this. Okay, fine. So yes, yeah, you are able to see now
Yes, sir.
automatic identification of payload. I will just give a very brief background of this payload. This automatic identification system, in general, before I get into the more details, in general, concept has been uses for quite some time. What it does, see, like we have a air traffic control. Similarly, ship also required to be having some control. Now, we cannot have a station in middle of the sea. So normally, what we have a base station, some of the coastal areas. So each ship transmits the information about itself. Means what is the type of ship, what is the speed, location, orientation, and so many things. That probably will come. And that will come to the base station. Now the limitation of comes at the base station, you because this communication always will be in line of sight, VHF range, line of sight. So once the ship comes very near to the coastal area, then only you can have a communication. Otherwise, you cannot have a communication. You cannot even identify. If you remember, several years back, there was an attack on Bombay. Why these boats, of course, such a small boats may not have AIS, but even if it would have AIS, the base station cannot identify unless they come very near to the coastal area. So there was a need all over the world that even they are middle of the sea, they should able to identify which ships are going, what kind of ships are going, are they authentic ships, or there is some sort of terrorist ships, or what they call uh, some of the sea dacoits and those kind of ships, or any such kind of thing. So there is authentication is required for such kind of application, and that is where. So obvious question came that if we monitor this thing through ship, through a satellite, so we have a large footprint, and they can vertically directly we can transmit the information, communicate the information. Like we have a geosynchronous satellite, you can see the TV signal all over the globe. If we have a three such satellites, we can always communicate. Otherwise, most 60%, one third of the surface area you can cover by single satellite itself, which was not possible earlier days when the satellite transmission was not there. Okay, there was only limited range. If you people, I do not know whether in your era there used to be a medium wave radios. They are line of sight radios. So the distance whatever is cover is one station you can cover only have 10 kilometer, 15 kilometer. Why it covers that way? Can you just say why it cannot go for more? Students?
Sir, due to the Earth coverage is
Right.
like the satellite coverage is very less.
No, no. Due to the earth coverage curvature, okay, line of sight is a limited area. Okay, you cannot have that line of sight. It can go only tangentially up to 10 kilometer. After that, like if you have a mobile tower, same mobile tower cannot communicate to one city to another city. Again, because of the curvature of the earth, buildings, and so on. Okay. Whereas if you are going for the satellite, you are transmitting the signal in the vertical direction. There is no restriction. You can go If your signal strength is sufficiently high, you can go anywhere far distance. Example is GPS. GPS, you are not finding any limitation as far as the distance is concerned. GPS satellite may be some 2000 kilometer away or something, but you can still receive the signal provided the signal strength is good enough. There is no restriction on that. Obviously, there is other kind of restriction. Suppose you are inside an RCC building, you cannot receive that one because of the structure itself will attenuate the signal. So the need idea is to tell that need will arise that AIS payload on a satellite means the satellite will work as a base station, communicate to all ships, and then get the information, pass it on to another base station for further processing. So that was the concept, and it is very, very useful. You can cover with a single satellite when it is a process a very large area. Of course, there is also limitation. If it is a near Earth satellite, the time duration is very less. But however, you can have a cluster of satellite all the time, like GPS. GPS is a cluster. You can always have a communication with the satellite. Okay, so that is one thing. But if you are going for geosynchronous, you can still achieve all the time. Satellite is available to you. You can achieve, but you imagine the amount of the signal strength required to communicate to GPS receiver, geosynchronous satellite. That will be very high. That may not be feasible for all satellite system. Of course, slowly now uh, many these things are coming up like a TV transmission, like home satellite transmission, and such kind of thing. But over a period, it may improve. But the presently, such AIS system, they are limited for the near Earth satellite system. So with this little background, I will just go to little bit more detail of anybody could you get this idea what is that AIS without I want to give that idea without getting into the full detail first.
Yes, sir, we got some idea. Like
Okay.
it's used to identify the.
Ships.
Yes, sir.
Okay. That will be used for various application. Nobody has, how many students are there in the class now?
Sir, 17, sir.
But how many have attended? I'm not able to see their, I don't know today what happens. Today I'm not able to see. 1 minute. Let me just see. No, I can't see. I don't know, something has happened. Either. Okay, doesn't matter. But I want to listen. Your name is what?
Anirudh, sir.
Anirudh. What other people are doing? Anybody
Sir,
else can respond? So, anyway, let us move forward and we will try to uh, do something better, whatever is the understanding point of view. So, with the little background, I will just move on to more details of this AIS system. AIS means Automatic Identification System. As the name says, I have already given the background that it identifies the ship. So this automatic identification system is an automatic tracking system that uses transceiver on the ship and is used by vessel traffic service. That is like air traffic control station and so. So what it does, it put one transceiver on a ship. So it can receive the signal from base station or it can transmit its information. It the transceiver or the transmitter sitting on the ship always keep on transmitting its information at regular interval. What interval depends upon, we will come back this thing in subsequent slides. We will come back and tell you at what interval they use. But it may vary from few seconds to few minutes, depending upon the type of satellite, depending upon the speed of the satellite, and so on. So when AIS was used as a for the ground-based station, no satellite was there. So it was considered as a AIS, normal AIS system. Now when satellite is being used, so what is now considered as a S satellite AIS. Okay, so this is what is now named as, but otherwise conceptually both are same. Simple AIS or satellite. Rather than communicating to base station, they are communicating to satellite. And satellite collects the data, analyze the data or whatever depending upon the capability of satellite, then pass the information to base station. There, some operators will be there, traffic control operators. They can say take the appropriate decision. But however, in future you will see lot of this artificial intelligence algorithm may be possible that today also may be doing, but it is not open so much in the literature. But lot of this AI algorithm may be used to identify the ship, to inform whether any collision can take place or what should be the next course of action for the ship, and so on. So, so this is called the satellite AIS system. Now, what this equipment, which is AIS, irrespective of, no, we will not keep on dwelling on whether it's a satellite AIS or ground-based AIS. Now, any AIS. Okay. What are the information it gives? It gives each ship is having unique identification number. Like all of us, we are having all Aadhaar card. That is also our unique identification number. Similarly, international agency, when the ship is sailing in the sea, they allocate some unique identification number. By that identification, you can identify ship characteristic, what is the size, what other thing is used, whether the commercial ship, whether it's a passenger, this cargo ship, passenger ship, or any other kind of thing. So each will have a unique identification number. Now, if this provision, as I mentioned to you, would have been there in 2611, probably we could have identified this terrorist some middle of the sea before they approach to the Bombay coastal area. And some of these attacks could have been avoided. But however, it's always learning. Okay, when there is a problem, you'll find a solution for that, and so on. So unique identification is done by some international agency. It also transmits its position. Okay, position where it is a part of the ship. Now, it was not possible for the ground-based system because it was no communication between, there was no possibility of communication between ship and the base station. So, but because of satellite, it can get the information inside when it is the middle of the sea, that we can get the information, position, course, which track it is taking. Okay, that information also you can find out. What speed it is running, that also matters. See, suppose the two ships are going on, they want to avoid the collision. Our ground traffic can estimate that yes, it is likely to be uh, no collision, so that some course of action can be taken on to avoid the collision. Other aspect, so these are the major thing. Now also it indicates some more thing, will later on we'll come back and tell. It also tells what is the angle it is taking. There are some equipments available which also take whether it's going linearly straight line or it is taking some round or whatever it is. Okay, all those information will come as a part of the course. Okay, what track it is taking and so on. Now, so how it is done? There is a transceiver at the ship level and the transceiver at the base station. Now, in our case, the base station is, what is the base station for our case? What we are studying?
Sir, racetrack in ISRO.
No, no, no. Base station for AIS, satellites. As far as satellite is, in this AIS is concerned, satellite based AIS is concerned, base station is satellite. That in fact connected to the ground based base station. Okay. Now this AIS transceiver, they are in the VHF range. Of course, that again varies depending upon the requirement. It could be the old standard and so many are there. So VHF receiver, which VHF transceiver, which can transmit or receive the signal in VHF band. Okay. And then also it is housed with GPS system. Of course, it is not a very, very significant now. Now even a small mobile is having GPS signal. So you are having a GPS receiver at this place. Then why we require a GPS? Anybody can answer? Other
Sir,
than Anirudh, I want to listen from others, whether you are listening or not.
Positioning, sir.
Huh?
For
Tell
the
me name.
knowing the position.
Yeah. Know its position, where it is. Otherwise, how do you know the position? Okay. Then there is another unit which is called the gyro compass, or we have also rate indication gyro, or which indicates how the satellite is taking the turn. So that is what is information. And GPS also can give what is the speed of the satellite. Okay. So that information also we can, because it gives a position, you take a differential position at some interval of time, you can roughly calculate the speed. We are not talking in meter per second, or we are not talking in that kind of meter per hour, some sort of kilometers per hour. So one can find out that indication. AIS also to be fitted in the internet. Now there is a compulsion that AIS is a compulsorily required to put on a ship which is a higher weight ship, 300 or more ton ship. Okay. So that is, they are all like international commercial ship or something like that. That is the international requirement when you are putting this information. But all the passenger ships are required to put compulsorily this AIS on the ship. Why? Because the risk involved is quite large. If there is a some sort of accident or something, a lot of human lives are involved. So always there is a just 1 minute. Always there is a compulsion that you should involve AIS. More safety is required to be taken for passengers. Okay. Now this gives a basic overview of whatever I have talked so far. This gives a basic overview that here each ship is transmitting to a base station, that is like our satellite base station. Now one can question, if all of them they transmit, there will be a collision. To avoid such collision, there are different kind of protocols are used. Like each of them will transmit in a slot, which is a randomized slot. There are multiple protocols are there. I will come back to that one, such that the collision doesn't take place. But in case the collision takes place, it will again the ship will retransmit after some time. After some time means suppose A and B ships are colliding, their messages are colliding. If both of them they delay by another 1 minute, then again collision will take place. But they don't delay by 1 minute. They transmit in a slot which is a random distance. Suppose this fellow transmit after 2 minutes, this fellow may transmit after 3 minutes. So the chances of collision is less. Collision in such kind of thing is always taken as a statistical means probability of collision is tried to minimize, and they will transmit the information under each slot. The slot characteristic, it is not very clear, but it is some 26.6 millisecond. That I will come back to the message characteristic in subsequent slides. Okay, so this is what the basic concept. Okay, now see why we require this kind of thing is the challenge. What is the challenge compared to the ground-based AIS and the satellite-based AIS? Ground-based AIS system will cover only a limited number of ships. But as we wanted to go, we have invited our own problem that we want to have a satellite-based AIS whereby I can monitor hundreds of ships in that whatever the square kilometer area. Okay, which was not possible during the ground-based. So that is the major challenge for such kind of, because as he says, the transreceiver which can transmit only 74 kilometer is at some typical number, need not to be a firm number, whereas it can go vertically up to any number. But if it's a near Earth satellite, 400, 500 kilometer is a typical number one can transmit. So that is where the challenge lies. Okay. Now, there are, as already mentioned to you, the transreceiver will transmit the information in both, and what are the different information? Position, speed, scores, navigational aspect at regular interval. What interval? It varies from seconds to minute. There are two types of receivers used in AIS, which they are in the ship. Okay, one is called Class A receiver. Class A receiver indicates that mostly the large number of ships, vessel-mounted AIS transceiver, which operate using self-organized time division multiple access. Many of you must have studied somewhere time division multiple access protocol. So it is a self-organized, means if there is a collision, automatically by itself it will organize. Okay, so that is what the concept of the Class A receiver. Okay, that so that the collision can be avoided. Now, TDMA requires a transceiver to maintain a constant update of slot map in its memory, such that it has a prior knowledge of the slot which are available for transmit. See, once this communication takes place with the base station, which is part of the satellite, this also get all the information from the satellite which slot is being used by other person. So what one can do, if I want to transmit something, if I know which slot is free, I can select that slot and transmit the information. So we can minimize the chances of collision. Of course, collision can still take place. If suppose two ships, they want to transmit and they are selected simultaneously, same slot, then there is a possibility of collision. Okay. This SOTDMA transmitter will then pre-announce that transmission, effectively reserving for the transmission slot. Once they know this slot is available, It can pre-announce, okay, I will be transmitting in this particular slot, so that other person, those who are not reserved, they need not to again come for this slot. So that is how, to the extent possible, actions are taken such that they are not uh, collide, messages are not collide. So SOTD transmissions are prioritized within their AIS system. There again a level of priority is involved. So this particular protocol message, they are given as a priority message. Sorry. So in case of the class V uh, system, class V transceiver, the international IMO is International Maritime Organization specification for class B. Okay, transmission aim to lighter commercial and the convenient small market area. So, but whereas the class 1, class A for always for the bigger satellite. Here also there are two options available. Either you can go like a class A type of receiver, or is a another protocol, carrier sense time division multiple access protocol, different kind of protocol, but it is applicable for smaller chips. Okay, so now we understood there are two class of trans receivers. Class A is meant for big satellites, big ships, and class B is for lighter commercial or some similar market. Okay. However, this also can have this class B, they use either CS-DDMA or they can use even SOTDMA as well. Okay. So now base station. Yeah, as I mentioned to you, base station should always have similar transmitter, transreceiver. Transreceiver means which transmit as well as receive. I hope you people understand this particular thing. So, to this transreceiver, which was earlier shore, which means the coastal area or something, they are always in SOTDMA. They are always in platform. Okay, base station have a complex set of features and function which in the AIS standard are able to control the AIS system and devices operating them. See, it is not just a simple SOTDMA. Some are in CS-TDMA, some are in different CDMA. Base station should handle all sort of messages. Okay, it should identify. Okay, and also it can, so that it should able to cater all the protocol, because that is a little more complex. Okay, and it also ability to integrate the individual transceiver of the status report. Suppose there is a some confusion or not able to resolve the two satellites, two ships. So this base station can integrate the individual transceiver. Okay, if there any change in frequency, that is normally they will have some dual frequency or something. So all those information it can also integrate. Whereas the AIS on the ship cannot integrate. So base station is a master station. Okay. So one application of this thing is add to navigation, because in the this also requires somewhere in the middle of sea, if wires are used to indicate some information, but they are not like ship. There some transceiver can be put on the for the navigation purpose, because if you want to find out what is their position are well known. So they also keep on transmitting. Some ship can receive that information in case they are matured enough. And designed to collect and transmit data related to sea and weather condition, as well as the relay AIS message to extend network coverage. So this BIOS, all of you are aware of that. What is BIOS? In middle
Yes,
of
sir.
the sea, there is a small station which works like a some sort of post box type of thing, which can pass the information to other part of the network which are not covered, or it, as it says, it related to the sea condition and weather condition, it will transmit the message so that this information is available to all. Another kind of receiver, what is used in AIS, is search and rescue. See, there is an international organization. Now it is compulsory that each of these things should have some sort of distress receiver. When the ship or aircraft or any such thing, they are in distress, they will transmit some important message like earlier, some mayday, 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 that kind of thing. In other kind of information, they will transmit. Even for our satellite, geosynchronous satellite, it is almost mandatory to put search and rescue receiver so that it receive the signal, distress signal, and pass it on to the control station. Okay, so this is what is, uh, but they are on the pre-announced time slot because distress signal should not get into the collision and everything. So there are some fixed time slots are reserved for them. The device randomly select a slot to transmit and will transmit a burst of 8 messages per minute to maximize the probability of success of transmission. So this is what among the whatever is available pre-announce because randomly it will announce, okay, this particular slot I will transmit, and there will be burst of 8 times messages are there, bursts of 8 messages per minute to maximize the probability of success, because we don't want to lose any distress signal from any of the ship. So that is what the search and rescue thing. Now there may be multiple type of thing. I have just selected some few of them. Okay, so that is what we will cover. So now I will just cover message types, and then probably we'll go and take a break, and then we'll go for the next one. As far as the AIS is concerned, a standard says there are some 27 type of messages defined. There are, of course, some messages are also defined, but there are 27 major high level, top level messages are defined by AIS. Whereas certain type of messages which are numbered as 6, 8, 25. Now, this all 27 messages you can find in the literature, even in the Wikipedia, this information is available. Okay. Some of the messages, they are like a application specific messages. Means that allows competent authority to define additional AIS message subtype. Because suppose you want to, because of some requirement, either this emergency requirement or any such requirement, you want to define some additional messages, some messages are reserved for that kind of thing. These are both address type, means they can be address messages or broadcast. Address means it is targeted for a particular station, either ship or buoys or any other station, or it it can be received by anyone else. It's like a typical computer protocol. If you people have gone through, they are like point to point communication, or is like a broadcast message. All of them can receive. Those who are those messages, if they are relevant to them, they will take it. Otherwise, they can ignore it. Okay. So address message, obviously, once there is a address ASM address messages, they will have a destination identification. Okay, given by MMI, MMSI. Okay, Maritime Mobile Service Identity is again some number. Okay, they are not private and may be decoded by any receiver. They are general uh, messages. They are not like a private messages, though it is addressed for a particular ship, particular receiver. But other person, if they want to decode, they can as well decode. They are not like a private message. Okay. An AIS transmitter send following data every 2 to 10 seconds, depending upon the vessel speed while underway. If the ship is moving at the faster speed, it will transmit the message. Receiver transmit trans receiver will transmit the message at the faster pace, maybe 2 seconds. Slower ship may transmit at say 10 seconds. But suppose the ship is at the shore, it is anchored, okay, then it need not to transmit so fast because there is nothing much is required. Only once in a while information is required to identify where is this ship. Okay, then this can give advantage of efficient bandwidth utilization. Now suppose there are some 1000 ships or 100 ships. Each of them will transmit every 2 seconds. It requires so much bandwidth. But if out of 100, if 50 ships are at the anchor, they are anchored, then you need not to transmit to. So you have only 50 into 2 second messages only, and remaining 3 minutes is become very, very slow speed. So this is this is essentially to utilize or rather efficiently utilize the uh, bandwidth of the communication. Now, type of message, what it contains, already I discussed, is a unique identification, 9-digit identification number. Okay. Navigational status, whether is anchor or underway and not under command or some status. They are defined by whatever the protocol they are using. If suppose they are moving at some turning to some speed, that also will indicate it as a part of the message. It also gives what speed they are running. Normally, uh, they are running in terms of nautical miles. Okay, so like you can see the conversion, some sort of zero point 0.1 nautical miles is equivalent to 0.19 kilometer per hour speed. So some speed information is also there. But if they are running at the higher nautical miles, they will transmit at the faster speed. If they are running at the slower speed, they will transfer the message at the lesser speed. Position. Yes, we discussed the GPS receiver is a part of position. So position is indicated by longitude and latitude. Like you have heard in satellite, all the satellite position, they are in terms of longitude and latitude. In fact, when you receive a GPS signal, they are also indicating your position as in terms of longitude, latitude. Okay. But from this longitude, latitude, you can identify in terms of XYZ coordinates if it is required. Because there is essentially the with reference to something is a coordinate transformations. Course over ground is again with respect to the true north. True heading, which direction it is heading, that can be also given by gyro compass. Bearing its own position, that which direction the ship bearing is there, that also can indicate in this. Essentially, how the ship is moving. If you are moving in a car, sorry, if you are moving in a car, okay, how this information, what are the information are required to identify, to avoid the collision and so on. it can be done. Those information are passed on. Details of this you can see in literature, but otherwise every point will take a lot of time. But this will give the idea that what kind of messages it will transfer. Okay, we will take some 10 minutes break. We'll meet at 2:40. Right now 2:30. Is it okay?
Yes, sir.
Right now is 2:27. So we can make at 2:35.
Okay,
Okay?
sir.
Okay? Good. Meanwhile, I will just find out why I am not able to get that photos of all of you. Yeah, here I am getting. Okay, that's okay. Hello.
Sir, you're on mute, sir.
Yes. Okay. You able to see?
Yes, sir.
So, other information, whatever there in the message, that also I will just very briefly will tell. Details you will find in the literature. Type of ship, dimension of the ship. Means by this message you can find the complete characteristic of the ship. Okay, location, position, whether it is position system using GPS or differential GPS or other type of system, the multiple users are there. Its dot ship characteristics, what is its destination, where it is going, okay, expected time of arrival, everything is in UTC, universal time. Huh? Here it is a month, date, hours, minute, and then later on in other message it will contain the second also. So all this information will be a part of the chip. Bearing of the ship, as I mentioned to you, and the UTC second. That's what there is up to minutes, and it comes. Also, it will have IMO ship identification number. Is a some 7-digit code is given to that. So that is what. Sometime it will have not sometime it will also have a radio call sign. Like those who are familiar with the amateur radios, there is a call sign associated with that. Similar way, some call sign is associated. The ship name also can be there, but there is some limitation of 20 characters. So these are just information, nothing uh, which is required to be there on the ship. Now, a brief about the, suppose you have to design the receiver, what it concerns. Okay. Normally, this AIS transceivers, they works in autonomous mode. Means nobody is required to carry out. All the information is passed on to that. Suppose you want information from gyro, gyro is connected to that receiver, transmitter, and so on. Its speed value or location value, GPS, everything is connected. Okay, it transmit in two different frequencies. Some time back I was just mentioning 161 or 161. The two bands are allocated for this one. They are called some 87A, 87B or something, and use, and transmission rate is 9.6 kilobit per second, very low rate. Okay, and it also use some sort of Gaussian minimal shift keying. This is a modulation scheme. Okay, that is what is used, and they are use HDLC protocol for the communications. So these are just a characteristic of. Furthermore, VHF transmission of the different transmission, already I told several times, they are like a self-organized time division multiple access protocol, and organized in such a way that two ship will not be transmitting the information at the same slot, same time slot. And for efficient bandwidth utilization, they will transmit at the different speed, different transmission rate, means interval of time, different, not transmission rate, interval of time. Faster ship will transmit more frequently, slower ship will transmit less frequency. And the anchored ship will be having 3 minutes transmission interval. So that is already I discussed with this thing. Okay. Already mentioned, based on the protocol, each station find out its own schedule. Some cases required, they can pre-reserve the slot for that. A position report, one station fit into one of the total time slots are available 2250 slots. Okay. So this is what is every 60 second. This is the protocol says every 60 seconds for each frequency. AIS station continuously synchronize themselves to each other to avoid overlap of the transmission. Of course, if they are in the line of, if they are able to communicate themselves, then they are synchronized. Okay. Slot selection by an AIS station is randomized. Okay. So that is again randomized. Different kind of random algorithms are used somewhere every 4 minutes or 8 minutes. I say this is all statistical means algorithms are used such that the probability of collision of the message they are minimized. Okay. Similarly, some assignment and all those things they are there. RF characteristic already I mentioned. They are 87B, 88B, and this 161 and 162 megahertz. These are all fixed band, and they are also called the marine band because like ours is like many of this RF data is available like mobile band, GSM band and something like that. Similarly, these are also having some band. Simplex channel 87 use a lower frequency so that they are not affected by its location and can still use the designated and maritime mobile frequency plan. This frequency based on the earlier experience and statistic by many of the experts so that they are not much affected by other country. This location means every location uniformly they can communicate on this frequency. Then some more information. Of course, I will not get into some of the I already told. They are normally NRZ encoded data they are transmitting. This is those who are done a course on communication. They will know that what is NRZ, non-return to zero. Okay, that is encoded data and using GMSK. Just now I told you that modulation scheme. Then certain modulation index for any modulation some index is defined, so zero 0.5 is the index is used. These are all standard, nothing much to know, only just you should know when you are designing a receiver. And transmission rate is 9600 bits. So this is what signal can carry a maximum on 75 kilometer. Again, this was for ground based thing, but now the satellite based thing you can go 400 500 depending upon the power what is available. Yeah, this all those things I have mentioned. So there is a little repetition because I have taken this information from different places, and so there is a multiple protocols are used: incremental time division, multiple access; random access, time division, multiple access; fixed time division, multiple access; self-organized, multiple. This is most commonly used. Now, where these protocols are used, very briefly, one sentence. Okay, incremental time division access scheme allow a device to pre-announce transmission slot of non-repeatable characters. If it is not repeated, okay, this slot should be marked so that they are reserved for one additional frame. Suppose you already have a known data, you can reserve those slots. This allows a device to pre-announce its allocation for autonomous and continuous operation. This is used for data link network entry when it is a entry, temporary changes, and transition in periodic reporting interval. Suppose some transition or some reasons are required. That is what it is. Of course, this is only just an indication. You can go more detail in the literature. Okay, pre-announce or the safety related message. Suppose you want to have it like as I mentioned, the distress and so on. You can announce that one. So such kind of thing protocol we can use. Random protocol is used. Device need to allocate a slot which has been not pre-announced. Means you cannot allocate a slot which somebody else has pre-announced. Okay, so but it randomly allocate the slots. This is generally done for the first transmission slot or the message for the non-repeatable characters. Okay, so essentially this is what the randomly defined. Fixed allocation, again, this is used by the base station only because base station takes the priority. So that is what they do. SOT DMA, we discussed quite a lot. Could be from base station or from big ships, small ships with certain characteristics. Okay, this is a typical thing are there. Now, what is the for any protocol you require a message format. Okay, so this slot is allocated to 26.66 millisecond long. How we define total number of bits? If you take this bit rate, how much time it comes? That is how accordingly it is defined. So this is done 96,600 bits. Okay, each slot has a maximum capacity of 256. So you can find out how much time it requires. So you can calculate how much time is required for this way come out to be a 26.66 millisecond long. And this is SDLC protocol. What is the content? Data content 8-bit ramp up. For any first communication, you require some dummy data to be available. So they call the 8-bit ramp up information. 24-bit locking data, preamble data. And then once this is logged, receivers are logged, transmitter receiver are logged, 8-bit start flag, 168-bit payload data, 16-bit CRC, because CRC is a redundancy checksum, redundancy character, cyclonic redundancy check. Okay, there are certain polynomials are used, which is used in the computer language. And then stop 8-bit stop, and 24-bit buffer. Some additional requirements are there. So what is that 20? This is a sequence 0 1, some sequence are there, so that the receiver can lock, because with certain modulation receiver cannot lock by itself unless you send a particular 0 1 0 1 sequence. Start flag 7E, 168-bit payload data, 16-bit CRC, some using 16-bit polynomial. CRC normally requires some polynomial by which you can compute the checksum. 24-bit buffer used for bit buffering, synchronization, jitter, distance, delay, and so many other unknown regions. Okay, this if I take preamble bits, start bits, data bits, CRC, stop bit. So this is a typical characteristic of a message. Okay, so with this little background, I should say that AIS is a very important project. It is must like air traffic control, and it is necessary to have a communication across the globe. So that is what the thing. Where we can apply this information for the collision detection, avoidance, detection and avoidance, fishing fleet monitoring and control, maritime security, as I mentioned to you, some dacoits and sea dacoits, ocean dacoits, and all those pirates they call, that is available. Aids for the navigation, some direction, suppose the ship requires some navigation help, that can be. Search and rescue operation. Then accident investigation. If investigation is done, if this using this data, one can do whatever the things. Some ocean characteristics, whatever it is there. Infrastructure protection like buoys and other things, whether they are transmitting properly or not. All those things. Fleet and cargo tracking, statistics and economics. How many ships? Suppose somebody wants to know how many ships are crossing across that. All those information for financial as well as the statistics region, you can use this information and provide. So essentially, I would like to say this is very important project, and this requires lot of information, and if some innovation can be done in this area, one can always project to the thing. Of course, acceptance of that is not so easy. It has to undergo several level of reviews and all those things. Okay. So that is what I have. All these informations are available on net. Some I will give this. I think already he is recording the information. Okay, Otherwise, also I will send my all the information to Karthik. You people can go through. Many of this thing information is available in Wikipedia, whatever I have collected. But there are several books are also in cases required. Of course, books, standard books are not there, but one has to search inside the books, particular chapters or something like that. Okay. So that is what we'll do. And if some of you want to take up as a, one of this assignment, write down the full structured detail of everything. What is the configuration? What is the receiver configuration? This is what I expect from this. Now, before I move on to next topic for 10 to 20 minutes, okay, we'd like to discuss anything. If you have any confusion, clarification, questions, please come forward. Tell your name and come forward.
Sir, Anirudh, sir.
Yeah.
Sir, I bought the book Quintessence of Nanosatellite Technology.
Hmm.
Sir, in that book, like what Malik sir was taught is not there in the book, sir.
No,
Like,
no, that is not there. That is a very, very brilliant book. But whatever the Malik sir has given that notes, okay, that is sufficient. Otherwise, you have to, if you want to go through a little bit more, then what Siddhi book. That is one book. Then there is another book by Aggarwal, Geosynchronous Satellite by Aggarwal, B.N. Aggarwal. That is also another book. And there are some multiple books are there. If you want, I have a couple of books. They will cover, because what happens, each book no doesn't give the complete information, so we have to go through the separate books. Okay.
sir, for examination point of view, will it come as per Malik sir's teaching, or will it come as per the textbook? What
Mostly,
time?
mostly whatever we are teaching, we have diverted some of the information. I have circulated some question banks also. No, did you get?
No, sir, not yet. Karthik sir didn't.
Karthik, Karthik will
Send it, send
forward to
it.
you. Okay.
I'll
So
accumulate those things and I'll forward
yeah,
it.
yeah,
Forward it.
yeah, yeah. Huh? So that will give. See, otherwise, for each of this topic, there will be a full course. Normally, in some big universities, for an university, like system engineering itself is a big course. Attitude and determination and control is a big course. Now, suppose somebody is interested more in particular area. If I have that information, you can pass on the information to requirement to Karthik. I will pass on to you. Okay.
Okay, sir.
So, this payload, though I thought Venkatrao has covered many payloads, so he has to take less time. So I thought this payload I will cover little bit more detail. At least some part you will remember, whatever it is there. Apart, more than that, you can just go through the literature. Okay. And now anybody else? I want to listen from each one of you. Who else is there? Well, otherwise I will see from this thing. Yes. Anirudh and Veera. She's there or she's not there?
Sir, I'm there, sir.
She or he? You are he. Because
Yes, sir.
I could not find out whether it's a she or he. Okay. So, what is your understanding? What you understood something from the course or not?
Yes, sir, understood.
You have to be attentive little bit. Chandan? Hmm? Manoj? Everybody is keeping
Yes,
quiet.
sir.
Yes, sir. Yes, sir.
Okay. With no question. You understood everything.
No, sir.
Anyway, you go through more. I don't expect, because this is a diverse topic, you cannot expect, I don't expect everything you will understand in one shot. Next to go through. Manoj, is there or not there? Muted. Maruti, Maruti ready?
I'll go through the notes, sir.
Manoj Kumar? Manoj is, yeah, they are done. Maruti ready? Pavan Kumar? Reshma?
Yes, sir.
You understood something or not?
We'll go through the notes, sir.
Yeah, you go through the notes, but same time from basic understanding, you people have Sagar. Okay, I think some of you may not be there, or I don't know. Okay, but idea is that uh, try to listen to several experts, and then I would request that you people also go through so that you can understand little better way.
Okay,
Now,
sir.
I have another 10-15 minutes I will give. More after that, we'll have some more discussion if you want. Okay. Another important payload. It is store and forward payload. This is also used for some of the satellite. If I remember, long back I studied when China has launched one satellite, what it used to say, it only pass the message China is the red, and it is received by all over the globe the moment it goes. But in this case, it is concept is little different. It is not just a stored message we can pass it on. Now you know that we understood when Mr. Malik has taught you that synchronous orbit or polar orbit or this orbit, that orbit, the satellite is going through all over the surface. So it is like a carrier. If I give some information to a courier fellow, he can go and deliver somewhere else. Like you send information, some post form, give it to one courier in Bangalore. You want to deliver to Delhi. So there means they will deliver to Delhi. But you are not physically going there. Okay. Only thing you have to connect to the courier. So here concept is also very similar to that one. When the satellite is coming to, I'm talking here near Earth satellite because um, geosynchronous satellite, each user should require very high power transmitter and very big antenna to receive and so on. So what is required is here when satellite comes near to our ground station or our connecting station. Now come out of the AIS. AIS is base station is a different thing. Now this is like a regular ground station like we have for ISRO, STRAC, we have for geosynchronous satellites, ISRO in Hassan, Bhopal, so many other places. So once it comes to our place, we send the information to the satellite and satellite stores and also will tell at this longitude, latitude you deliver the message. How do we know longitude, latitude? Suppose my base station, my station, control station, longitude, latitude is some value. Similarly, for other station also, there will be longitude, latitude. Okay. So once we say this place, you can deliver. So it simply transmit the message at that time. Or other possibility, depending upon the capability of payload, you can say, you can predefine by using your mission software. At this point of time, the satellite will reach over this particular ground station. At that time, you transmit the message. Time is always referred as a GST time, universal time. They are now not local time at all. Okay, so they will transmit the message. This is the simple concept used in many of these things. One of our small satellite was also having this kind of information. I don't remember the name of the satellite, but one small satellite was having this information. Okay, so this is the concept for store and forward satellite. So what is now whatever I told you overall. So what is straight and forward is a telecommunication technique in which the information is sent to an intermediate station. What is intermediate station in our case? satellite. Okay, where it is kept and sent at a later time to the final destination or the another intermediate station. So the question is, store and forward concept is used in network theory, those who are computer networking. Similar concept is used here. So you can pass this information to satellite which is coming near our place. Just 1 minute, please. Sir. I'm in class after half an hour. So uh, what we have information is available, we can send it to the satellite, and then the satellite will receive that thing. If it is passing through the another ground station, it will pass the message. But some of the sophisticated link, if they are available between satellite to satellite, it can pass on to different satellite, and which can transmit the message to the required base station. Depends upon what kind of sophistication we involve here. It can be from one ground station to the satellite to the other ground station, or it can be one ground station to the satellite to other satellite to the final base ground station, or it can be ground station to the satellite to the ground station to another satellite and then to the final ground station. Depends on what kind of provision, but concept is very similar. I have one small animation that probably I will show you. So this intermediate station is called node. The concept is very similar to computer networking. There is nothing different. Okay. So this intermediate station, which is in our case is a satellite, is called as a node, which is also called the computer node in computer networking area. So you can imagine that way. It's like a computing node. But it simply doesn't. There is a two type of message. One is simply like a post box. Receive the message, forward the message without verifying. But in this case, it is verifying the integrity of the message, means whether the message is valid, whether the message is not corrupted, all the required format and everything is there, they will send. There all the networking technique can be used here. And then after that, it will deliver to the final destination or another intermediate station, which can be then final, which can again transmit to the final destination. This is the concept used for store and forward message. And obviously, this system cannot be a real-time services. Why? Can anybody answer? Why it cannot be real-time?
Sir, it takes some time to process the message.
No, because the real-time means when I'm transmitting, the other station also receiving the same time. It is not possible. The satellite, if it is on my ground station, it will reach after some time to that ground station. So it cannot be real time. So that is why the thing. Processing is, yes, is one thing, but processing is not the major reason, because satellite is not visible to all ground station simultaneously if it is a near Earth satellite. And this information is essentially for the near Earth satellite, because the geosynchronous satellite, they can also receive the real-time information. But what it means by real time? The transmission delay, sending a signal from ground to geosynchronous satellite and from satellite to again ground station. That much delay is required. Some order of, you can calculate based on the speed of velocity of light and distance, around some 400 milliseconds or some delay is required. That's why olden time, when there was no fiber cables across the countries, across the continents, okay, there used to be a lot of delay. When you talk something, when somebody responds, there used to be a lot of delay. But now, of course, this is taken care by fiber cables lying across the um, contingent, different regions under the sea or whatever may be the means. So that is why it is not a real time system. Okay. A stored and forward switching center is a message switching center. It's some nomenclature in which the message is accepted from the originating user. Means suppose if you want to transmit the message, it will go to the message switching center, which is our case, it is a satellite. An originating user is a sender. Okay. When it offered, held in the physical storage, then a satellite should have enough storage to store this message and tag this message when it is to be forwarded to the required destination. That is important. Okay. So that is a very, very important thing, that whatever the satellite we are talking, they should have enough storage. Suppose you can't restrict, only one user can transmit. There can be many more user. Again, based on certain protocol, you can transmit the information, how much information. So there should be provision for storage on board the satellite. So that will receive the message and then it will transmit to the place where we want to deliver the message. Okay. So that is why priority and all those things again depends. If there is a multiple message, availability of the channels, availability of the ground station, all priorities are whatever the computer networking site they have, they will be having the similar kind of priority of the message. Where we can apply such kind of thing. Of course, the format and all those things I have not gone through, but it's conceptually some format one has to have, or if you have access, you can design your own format and pass it on the information to them. But it should be compatible with the satellite, compatible to the receiver. This is very, very important, I should say, the application for small satellite. With less in hardware, you can pass the information to the required destination. Okay. It is like a post office. Okay. Post office doesn't transmit your information in the real time, but it takes your post and after that it delivers to your place. And olden time we were very happy with that. Now, of course, email immediately transmit this, that, and all those things are there. But if real-time requirements are not there, this is an ideal requirement. Suppose you have a polar satellite, as last time Mr. Malik was mentioning, the polar satellite keep on revolving around the Earth, and every hours it keeps on shifting the orbit. So this information can pass on to the global anywhere. It can transmit electronics, mail, some voice you can message, or image. Somebody wants to send a congratulatory message to someone, that you can do. Somebody transmit that, like our internet nowadays, WhatsApp and all those things, images you want to transmit, or some computer data or any other data. Data is data for this transmission. So all those application can be built into the satellite. And this is a very easy means, very less expensive system. Now, pictorially, if you want to see, I can show this one. Suppose we transmit the message at one place. Now your satellite is moving all around. Wherever the ground station comes, it will release the message. Okay. So that is why now slowly over a period, after some orbit, it will cover. You will just see it covers almost entire globe. Okay. So that is where we can have this kind of satellite. And yeah, just see for a few minutes, this will be covering almost complete globe. Only thing is that time delay. Depends. Suppose you want to send a post. If it is within a Bangalore, it will get early as possible. But if it is out of Bangalore, Karnataka, it will take some time. Out of state, it will take another time. Internationally, another time. So such kind of thing is there. Of course, here there is nothing like a state boundary or city boundaries. It depends upon the satellite orbit. So this is what I have. Any question on this aspect? Anybody can suggest this kind of information can be used for what purpose? Can you think? We have still 10-15 minutes time. We will discuss this aspect. What could be the more potential? Traditional areas are always there. I want to listen from students. What kind of areas you can think that this kind of concept can be used? Think openly.
Sir, like for areas where there is limited connectivity, we can use direct satellite.
Yes, for satellite primary reason is to place where our ground network is not available. You can go for it. That is okay. What kind of information application I am asking? See, you people, are you aware in some of maybe some, I don't remember the exact number of years. Some years back, there was a great tragedy in Uttarakhand near Badrinath, Kedarnath, that area. Okay. Do anyone of you remember?
Yes, sir. The flood that killed many people.
It was not flood. It was like some sort of lot of this water was coming from the top, and all those things they call natural disaster, and cloud bursting, and all those things were there. Now, even if you have a terrestrial network, it is not going to help. See, what is required is that if there is a terrestrial line, there is no way of communicating through them. But in such kind of no panic situation, if you have some means to send your information to your relatives and friends or parents that I am safe, there will be great satisfaction. Now, the satellite, with this satellite, you can quickly have a temporary ground station there, keep on transmitting the information, and it will keep on delivering different places, and then finally they can always receive the message from your receiving station. So that is one area. In such kind of thing, natural disaster is one area, and it's one condition where this kind of information can be used quite a lot. Quite a lot one can use. And of course, if you are not interested in having the real-time transmitting, you have given something, okay, sometime let it go, like our email. Now, our email speed is so high that immediately almost we feel. But the concept is similar. We send, go to the server will go send this information to required destination. So, but if time is not a constant, you can always send this information to them. Whether it reaches now or after 10 minutes, it doesn't make any difference. Then you can use this services. You can, what other thing we can think of? Anybody else?
Sir, islands. In island, if a man
In
is stuck.
island applications where we don't have infrastructures, okay, at least this is a sure and certain things one can send the information, and that is what one can do. There are plenty of things one can think of, such kind of applications. Okay, suppose another interesting application is a wildlife tracking information. Okay, now many of you may be knowing in the wildlife they put this all the line and all those things, they put a color, radio color. If suppose this information can go to a satellite, either they can directly transmit into a satellite, or there will be a local station which can collect the information, send it to that one. Throughout the world, I'm not talking the secret message, I'm talking the which is interest for all. Those messages can be received by anywhere. Anywhere we can find out, oh, this particular, suppose you want to visit a lion safari. Okay. You can see at what time of the day lions are coming there or another animals are coming there. You can plan your visit. Plenty of things can be done on this aspect. So that is where one can think of. Okay. Anybody else? Other people, they don't talk. Hmm? Okay. Doesn't matter. But as long as you understood, this is well and good. So now the question is that payloads, earth observations, optical camera, infrared cameras, spectrum means multiple spectrum, some communication payload. These are all communication payload. Now, ionospheric, we have not, you go through that thing. In case if you want me to give, I can give. But this is an assignment. Karthik can give it to people. What kind of payloads are used for ionospheric effect study? See, I think Venkat Rao was mentioning something that you can monitor the characteristic of the ionosphere at different height, okay, different temperature. With that, a weather forecasting person can study and predict certain behavior of the uh, environment. Laser communication is one thing, particular when you want to have a satellite to satellite communication or satellite to ground communication and so on. You can use. He has discussed that aspect for in terms of ladder, that vertically altimeters and so on. So such kind of payload, I can, if I have this payload, I can find out what is the height of the satellite, or I can from the satellite, I can, as you mentioned, if it is taking the slant range, I can find out the height of the mountain. I can find out many things. So these parts, I leave it to you people. You must study, but some question may be asked on that. Okay. So that laser communication, scientific payloads related to study of sun, study of galaxy, study of far more, no, uh, any other this thing, uh, stars or something, or some one project that we are working on, that study of UV rays, means stars, they will emit UV rays. To find out where are the sources of UV rays, map the sky. Such kind of scientific payloads can be done. So you just, at least you should know the name of the payload. You should what kind of payloads one can make use of these applications, scientific payload. Okay. There are those who are interested. I was just recently going through, even NASA, they have a satellite. Any one of us can access that data, particular the satellite called Aqua satellite. Okay. You can access, you can go through the details and you can acquire the satellite. You can also pinpoint something if you can. Okay. You can process the data, you can receive the data. Okay. You can generate some new algorithms so that you can identify certain glacier, you can identify certain river or flooded regions or marine animals, some cases, like he was talking about, Venkatrao was talking about fisheries purpose and so on. So all those information, if it is available, one can use as a lot of, as a business model. Some, of course, some companies, they are using as a business model. One can always get into that kind of thing. Okay. So the next lecture will be on thermal control aspect. See, attitude control is one thing, but thermal aspect is very, very important, because the satellite, once it is a launch, one side which is showing the sun is visible, because there is no atmosphere, it will not attenuate the sun rays, the temperature will be very high. Whereas the other side, when the sun is not visible, the temperature will be extremely low. So there will be a lot of distortion will take place. There will be impact of instrumentation or the satellite subsystem performance. What is required? You have to maintain the temperature of the satellite to a good extent, somewhere between 20 to 30 degrees. Okay. The person who is going to give the details, he himself has designed a lot of thermal control system for different satellite. And before launching the satellite, he was so meticulous in modeling. You can predict within 1 or 2 degree. Okay, he was able to predict the temperature of the satellite or its subsystem. It was so accurate modeling. So please listen to him. And many of you people are mechanical system people. Even some of the project can be taken up for such kind of thing. That will be a good thing. Another module, I say, a part of this module is a structure aspect. I am also trying to get one expert, Dr. P.S. Nair. He is an expert right from beginning of Satellite Center. Uh, he was in charge of the structure design. He has a very big experience. I would request whether you want to do in satellite, whether you want to do in aerostate or any other application. He's an expert in structure. So I would request, you can request Karthik and HOD through him. You can take some project, do project under him. You will learn quite a lot if you work under him. And nowadays you need not to go personally. You can always run. But only thing whether he will able to take or not, that probably be nice to discuss. You can ask during your during the class itself that if you have some idea, keep idea ready. He is very, very enthusiastic. If you project some good idea, certainly he will be willing to cooperate with you people. Okay. Now it is up to you how to take advantage of such situation. Okay. Yeah, please.
See to it, sir.
Okay.
Yes, thank you.
And then we are going to have maybe after your this term exam, we will have a discussion on the communication system and the power system. Power system is not mentioned, but I felt it is very, very important thing. At least couple of lectures you should have in power system and some lectures on communication system, some on the command and telemetry system. That is what is planned. And if time permits, of course, this is very, very important. Not time permit, I will certainly make sure that at least couple of lecture on reliability aspect. That is a part, because that is the difference between a project doing for the ground-based system to the onboard application. Okay, that also. Right. All of you got that books.
Yes,
Whatever.
sir. I bought the first textbook, sir, Quintessence of Nanosatellite Technology.
So, and some of our library also must have received the book.
Sir, I didn't go to college yet because it's
Acha, acha,
online.
yeah, that's true. That's true. Okay. I don't know how much it costs, but better you can have some reference book so that some of the information can be given. Okay. I will also try to get some soft copy of not that book is soft copy is not available. Some other books which also gives quite a lot of information. Now some books will give more, some books give less, and all those things will be there. But there is another Indian author book I saw. That is also, if just 1 minute, if it is, mm, you have a time, no? Yeah, still you have 5 minutes time. Let me see. If I have that book right now itself, I will send. I thought that is also a quite good book. Just 1 minute, wait a minute, huh? Just workshop presentation. Thermal. If I can easily locate that book, I can tell you. I think I have to search. I was having that soft copy of that book. Okay, I will try to pass on to Karthik in case if I am able to locate. Okay, then probably we can go through that one. Okay, so Karthik, is it okay?
Yes, sir.
Huh?
Yes, sir.
So is okay for the day?
Okay, sir. No problem.
Huh?
Yes.
So that is what I hope this is students. I think before the first term exam, we will finish communication and thermal. Not sorry, structure and thermal. The remaining part will take for the second. Will that be okay?
Excuse me, sir.
No, first term exam, which is going to take place by end of this month. Okay, we'll go up to thermal and structure. These two more topics we'll cover.
Okay, sir.
Okay, then next term exam will take communication, power, digital systems, and whatever the remaining things are there. Okay, and then if time permit, if you want to repeat something, we will repeat that thing. Okay, and if I would prefer if we can do some simulation, that also in case some exercise is required. Acha, one lecture we planned to be given by Mr. Malik on some designing of a small satellite, the high level. That will give a lot of ideas. I don't know when he is going to give, but let us see. Sometime we will give it. Okay? Okay then. Bye.
Thank you, sir.
Bye.
Thank you, sir.
Thank you, sir.
Bye.
Thank you, sir.